Gracie, did you find the go live button in YouTube? There we go.
It says live on my Zoom.
All right, we're going to go ahead and get started here. Welcome everybody to In the Cosmos from the De Anza College Planetarium. And I'd like to wish everybody a happy International Observe the Moon night, sponsored by NASA here. My name is Toshi Komatsu, and I'm the director of the De Anza College Planetarium. And although we would love to be doing this live in this world that we're in now, we're doing a virtual thing. We do have a couple of people on staff here helping us out. In particular, I've got my good friend Mike, who's got his own telescope. Maybe I'll switch over to his view just very briefly. But Mike, if you could say hi to everybody.
Sure. Hi, Toshi. Thanks for the intro. And I'm looking forward to showing you as much stuff as I can show you with the telescope I've got here. It's a little Meade telescope, about 4 inches objective. And we're going to look at the moon tonight, and we'll discuss a few of the features that we can find there. So back over to you, Toshi.
All right, thanks, Mike. So what we're going to do here is we're just going to what we would like for everyone to do is hopefully you've logged on with a smart device that you can take outside, and the hope is that you actually go outside and take a look. And we're here to show you where to look, but we're hope that you are outside, hopefully wearing something warm. I know it was kind of a warm day, but if you're outside for a while, it does get warm, or it does get chilly fairly quickly. So hopefully you have a jacket. Or something even light, just to keep yourself a little bit warm as you go outside. But we do want to go ahead and encourage you to leave comments on the YouTube chat. We're also here to answer your questions. So if you do have any questions or you have any comments you'd like to share in the YouTube chat, we'll be keeping an eye on that. And as Mike said, again, we'll be taking a look tonight here at the moon and maybe mentioning some planets and maybe a couple mentions of bright stars as well. So if you're not outside already, now's a good time to go ahead and step outside. Again, make sure you have something warm around you, and first job is for you to find the moon. And we'll get to Mike in just a little bit. What I'd like to do is actually switch over to a bit of planetarium software called Stellarium, which is what we use for our virtual field trips, which are starting up here. And what we're looking at, or what I've got centered on here, is the moon, of course. And to find the moon tonight, you want to be looking towards the southeast. It's sort of between south and southeast at the moment. And this is the current time that we're looking at in Stellarium, where we can do all sorts of things. We can go faster in time and backwards in time, but we'll keep it on the current time here for a star party. And we've got the moon. And if you're outside already taking a look at the moon, then what you might notice is that there are two bright things just to the right of the moon. And the closer one to the moon is actually the planet Saturn. And the brighter object that's a little bit to the right of Saturn is actually the planet Jupiter. And if we have time, we'll take a look at Jupiter a little bit later on. But of course, we want to be focusing in on the moon here. It's a gibbous phase, and which means that it looks like it's a little bit more than a quarter moon, and but less than a half or less than a full moon. International Observe the Moon Night, again sponsored by NASA, is always chosen on a date in September or October, which is closest to the first quarter moon. So we're just a couple days past the first quarter moon. So we're focusing in on this gibbous moon that we have here tonight. And just visually, when you're looking at the moon, a lot of times you see these darker areas on the surface. In Stellarium, I can zoom in a bit closer here. Let me go ahead and I'll center in on the moon and turn off these labels here for a moment. And we can zoom in on the moon. And even if you have binoculars, which again, hopefully you have, that just helps the view, although not necessary. But when you look at the moon here, you can see again these dark areas, which are called maria. They're where ancient lava flows on the moon. And then you can see some craters as well. And we're going to be focusing tonight a lot on the area of the terminator, which is the boundary between night and day on the moon. So we've got the sunlit side of the moon, and then we've got the nighttime side of the moon there. And this is where you get a lot of interesting detail when you're looking right along the terminator. So sometimes people think that the full moon must be a great time to look at the moon, and that's actually the worst time to look at the moon. You don't want to be looking at the moon when it's full, mostly because it's very, very bright, but actually all the detail gets washed out. So we try to avoid looking at the moon with a telescope or even with binoculars on a full moon. But on a gibbous night, a first quarter moon's pretty good. But the moon's always changing. It's the one thing in the sky that actually changes from night to night. So there's plenty to see on the moon and plenty to see tonight here. And there's a lot of, again, craters on the moon. There's mare, and there are a lot of mountains on the moon. And this was something that really surprised Galileo when he, over 400 years ago now, first looked at the moon with his telescope. The expectation, sort of before the telescope, was that the moon would be this completely smooth, beautiful thing. But Galileo, he discovered that there were these mountains and craters on the surface there. And so he took great delight, made a lot of sketches, and that was sort of the first time people were able to observe the moon, starting about 400 years ago with the invention of the telescope. Speaking of the telescope, I think we'll go ahead and switch over to Mike so that we can take a look at his view through his telescope. So, Mike, will spotlight your video here and let you take it away.
All right, Toshi, thanks. Well, just want to tell everybody, so I'm viewing from Los Gatos here, and we do have a little thin layer of cloud, but it does seem like it's moving away, so I'm encouraged by that. It looks like it won't hinder our view too much. Look closely at the view here through the telescope that I have here. It's hooked up to my phone, and then my phone is communicating into the meeting. So it's quite a spectacular technological thing going on. Anyway, right very close to the middle of the screen. Um, well, before we get started with the features, maybe I can point out to you, some of you may be wondering, why is it underwater? This is the moon, right? We're looking at the right thing. It's not underwater. We're looking at it through the Earth's atmosphere. And this is a great example of how the moon's or the Earth's atmosphere really makes it difficult to get a clear view. And that's why astronomers, one of the big reasons that astronomers want to get away from the Earth's surface and to get out into space, to have observatories, space observatories that don't have to look through that atmosphere. We're trapped with it tonight, and thank goodness we have it, right? Serves its purpose. The crater, the spectacular crater that you see right on the edge there, and by the way, the line that separates night and day on the moon is called, technically, it's called the terminator. The terminator. And that's where we're looking, and that's where we get the best view because we get the best contrast. And what I'm going to do is use the controls here to try and get uh, the crater that I'm interested in starting with here, the crater Clavius, right in the center of the view. So let's see if I can get it close to the center here.
And that crater that Mike is talking about, it's the one, it's kind of just below center in our view here, but it's the one that has three pretty obvious smaller craters within it. And that's something that you see every now and then. You have a crater that happens, or when something runs into the moon and leaves a hole. Well, after something, after whatever it is forms that hole, there could be ones that happen a little bit later on, other meteors that come in and leave craters afterwards. So seeing craters on top of craters, it's one way that astronomers actually date craters, is noticing, whether you have new ones or older ones. You can tell the older ones because they'll have newer ones inside of them.
Now that crater Clavius, just to give you a sense of scale, it's like 143 miles from one side to the other. It looks like it's an oval, but it's actually fairly circular. It's only our perspective in looking at the crater that makes it appear to be sort of ovalish, but it's really quite round. If you look at pictures of it online, you'll be able to see that. Also, to the right of that great big crater is a much smaller crater. And I think I mentioned to you about 143 miles from one side to the other of Clavius, a couple of miles deep. We're going to look at a different crater. I'll try and move things so that that smaller crater by the name of Tycho is right in the middle, and I did a pretty good job there. You can see that there's a bit of a shadow on one side at the top, and there's a bright sort of light on the other side. That's the crater Tycho, and that's a um, relatively young crater. In fact, it's believed that that crater was made by an asteroid impact or meteoric impact about 100 million years ago, which is young in astronomical standard. Let's see if I can move over a little bit there. Toshi, you're understanding which one I'm talking about there, Tycho, right? That's
Yeah,
the
and that
name of it.
crater, it's the one that again there's a bit of shadow that you can see in the upper part, and then it's a bit brighter on the lower part of the crater. But people might also notice that there's what looks like a bright spot at the in the center of that crater, and that's actually a central bulge, and that happens sometimes when with larger craters. And if you've ever dropped a pebble in some water, and sometimes you get that little bit of water that pops up from the center. Well, that's what happened, except with the molten ground, the molten surface of the moon, is that this meteor comes in, crashes into the surface, and it liquefies the surface. So just like when you drop a pebble in water and you get a little bloop that pops up in the center, that's what that central bulge is there. It's molten surface that bloops up, for lack of a better word, and then it solidifies, and so you get this mound in the center. So certain large craters have that central bulge, and it's evidence of an extremely energetic impact that again released so much energy that it liquefied the surface so that it acts just like a pond, or just like bath water, if again you're dropping something in it.
Well, let's go ahead and start moving up the Terminator here to see what other things we can see. Again, I'm going to stick mostly to things that are right on the line between night and day on the moon there, so that the contrast is the best and you actually get the best view that way. So I'll move over just a little bit here.
And while Mike's moving over to our next target, I will say that again, the reason why we don't want to look around the full moon, but instead we want to look around sometime when there's still some shadow. Again, first quarter moon is ideal, third quarter moon works too, but when there's some shadow there is because if you look right along where the terminator is, that's where you get these dramatic differences in shadow, and you can tell like that central feature that Mike is centered on there, that's a little bit of a what looks like a little bit of a mountain range there. But then you get these shadows cast by the mountain range. So it gives it a really dramatic effect. And again, you can look at a couple of the craters that Mike has zoomed in there. There's two, again, sort of central, but a little bit towards the bottom of our view here. But they've got some nice shadowing at the top there. If we were looking on at full moon, you don't get those shadows. And so the moon actually ends up looking fairly flat and it looks fairly boring, but it's the shadows that give it this really three-dimensional effect. And so it's worth taking a look at while there's some shadow and right along the shadow. And it doesn't have to be tonight, but any chance you get a chance, if you have binoculars, to look. I highly encourage you to look right along the Terminator, look along the shadow of the moon there, and you get the most dramatic features right along the Terminator.
And right close to the Terminator tonight, Toshi, as you know, is a very prominent crater. It's called, named after a famous astronomer, Copernicus. The crater Copernicus is right there in the center, at least in my view here. And very close to the Terminator there, so you get some nice contrast between the light and the shadow. And there's also some little mountains that are sort of close by there. Um, and let's see if we can keep moving here. You can also see a feature called rays. And they're sort of streaks that are white streaks that are coming out, aimed sort of in the direction of the crater that was responsible for them. Those rays are found all over the moon. Tycho, that crater that pointed out to you a little bit earlier, um, has very bright ones, and you usually can see the rays more when you're looking at a full moon than you can with when we have this high contrast at other phases. So I'll keep moving here.
And just a little bit about rays for people. So before I gave the analogy of some water and you're dropping a pebble, with rays, imagine instead you have, and I've done this experiment with students, and you can try this at home. Maybe get your parents' permission. Make sure you have a nice sort of clear area. Maybe even do it outside. But if you get a tray and you imagine a tray that's filled with flour, that is something white, and you cover that flour with something darker, like cocoa powder, is the classic example, and you take a pebble and you drop it into the flour with a dusting of cocoa on top of it, what happens is the rock drops into the flour and makes a crater. But some of the stuff that was underneath the cocoa that gets thrown out in rays, and they go radially in all directions. But you get a trail as the stuff from underneath the surface is thrown up and then deposited on the surface, and that's what makes those rays. So the darker areas on the moon, as I said, are ancient lava flows, and just like lava flowing on Earth, it's a darker color. But underneath, the rest of the moon, right, is a lighter whitish color, and so that's still underneath the darker Maria. So when an impact comes in, the lighter material that's underneath the darker Maria material, it gets thrown up in some of these, again, these larger impacts, and they again get deposited, and they look like rays that extend out from the crater.
And so you can see some of them on some of the flat area there with near Copernicus. The other thing, I went a little bit too far north too quickly, though. I wanted to show you so a mountain range called the Apennine Mountain Range. A lot of times, and it's right there going up the middle of the view. And I believe there was one of the Apollo missions landed right among what the little mountains that you see there. Can you remind me about which one that was, Toshi?
Yeah, that was Apollo 15, which was sort of on the towards the northern end of that mountain range. So in our view here at the bottom, there's a crater that looks like it more kind of marks the end of the mountain range there. If you follow the curve of the mountain range up and to the right, going starting from where that large crater is, up and
Yeah.
towards the right, almost at the end of where the mountains where they end, that's where the Apollo 15 landing site, or close to it anyway.
Okay. And those mountains are right on the edge of a giant circle called Mare Imbrium. Mare Imbrium is the biggest mare region on the moon. It's over 1,000 miles, or something like 800 to 1,000 miles. You have to look that up just to make sure that I'm getting the numbers right there. But it's by far the largest of the Maria on the surface of the moon. And so the Apennines mark one part of the edge there. I can't zoom back enough here. Actually, I might be able to zoom back a little bit to see if I could show you a little more. Well, I
But
don't seem
if
to be able to do that at the moment.
Well, if everyone
That's
notices those three craters that are to the right of the mountains, they kind of almost make a little right angle,
yeah.
just kind of to the right. So that's part of Mare Imbrium. And as Mike said, that's actually, it's 1,000 kilometers across in diameter. So that's about 700 miles. So again, that
Wow.
is the largest basin on the moon. And the thing that created that impact is estimated to be about 250 kilometers. That's 150 miles or so. So again, these very large objects that were flying around
Hmm.
the early part of the solar system. But Mike's got a good view of Mare Imbrium now, and then there's even like a little crater that's sort of the edge of the Mare there as well.
So we're at the we're at the northern end of the moon now. The northern part is to your right, and you can see at the very top there um, some interesting contrast in some of the crater-like um, features up there. I can go to the very top here. Whoops, wrong way. I've got a couple of mirrors inside the telescope, which really flip around the view, so it makes it difficult for me to get clear. And I'm sorry to jerk around a little bit, but it's astronomy. What are you going to do? So let's see. If we look, you can see right at the edge there, and again where it sort of starts to smooth out. That's really the very northern part. Is that coming through, Toshi? Can you see that?
Yeah, looks like it's coming in nice and clear there. Again, the beautiful contrast with the Terminator there. There was a question in the YouTube chat that we saw about what was that little spot in the middle. I think that was kind of back when we were looking at Tycho crater, and again that little bright spot in the middle is a central bulge, so a little bit of extra molten surface that like a reverse water droplet that probably got shot up during that initial impact, and then when it settled back down again, it solidified into a central mound there.
Well,
So
and they may or may not have been talking about the one that you pointed out, Toshi. But as you also led us to understand that it's a very common occurrence to have a central peak, and you may be seeing craters where it's dark in the crater, but only the central peak is lit up. That's a very exciting view to get because you're just it's like the sun is helping you sort of see first a little bit and then more and more and more of the crater as as the lighting conditions change. Do I have time, Toshi, to sort of go back fairly quickly, sort of down the trip here, or do you need to move on?
no, I think we still have plenty of time, Mike. So
Okay,
whatever
great.
wherever you'd like to take us.
Well, let me. Oh, you're gonna give me the steering wheel. All right. Well, let's go ahead and move a little bit back down. I'll try and show you some stuff that you didn't see before. And there's a big portion of Mare Imbrium. You're talking about that huge. And by the way, I don't think you talked about it, Toshi, but there's difference between the smooth parts of the moon and the parts that are much more mountainous. Those smooth parts are smooth because of giant flows of lava in the very early days of the moon's formation that flowed and smoothed out a lot of what otherwise would have been rough. So a lot of times you'll see some very smooth areas with just some craters on it and just a few. And that's because they came after the flow of lava. So Toshi also intimated that you can tell something about the age of craters by sort of just looking at which ones are on top. And that's essentially what I'm talking about there. Let's keep on going back down here.
Yeah, just to add on to that, so if anyone's ever been to Hawaii or any place with volcanoes, and in particular shield type volcanoes, where you get that lava that flows and it covers up everything. So if you look at places on the moon that are not covered by the darker areas, and there's many more craters. In fact, the images that we got back from the space missions that went to the moon and looked at the backside of the moon, there are many more craters there because there are less Maria there. So when the Maria, again, they're ancient lava flows, and they covered up any older craters that might have been there and gave it a fresh start. So again, as far as dating things on the moon, you have impacts that were happening all the time as once the moon first solidified, and then so that covered the moon with these craters all over, craters all sorts of shapes and sizes, and the view that Mike is showing us now, you can see dozens and dozens of craters there. But the Maria, again, when those lava flows happened, they covered up all of the craters that had been there, and but that was still early on in the moon's history, and so you still had some things flying around. And that's why sometimes the craters on the Maria, sometimes they tend to be the most dramatic because they look like sort of isolated things there. So again, if you imagine sort of like, a freshly covered snow somewhere, and you walk through footprints, you get those fresh footprints because everything else got covered up there. So.
Well, let's see here. Got a little extra time. Let's go ahead and take a look at some of the brighter part of the moon and see what we can see. Again, I've been sort of sticking toward the Terminator because that tends to be the best contrast and the nicest view. But as we go across the surface of the moon here, we might also see some more Maria. Let's go to the other side here. Oh, there's a real dark area. Whoops. Come back.
So part of what's going on in our view here is, so Mike is sort of scanning along his view in the telescope, but there's also the fact that the moon is drifting in space as well. So even though it might not looking at it, if you're just staring at it just with your eyes, the moon is actually very slowly moving. And when you're looking through a telescope, Mike's telescope is able to track the moon as it moves in the sky. But the moon is moving, Earth is moving, the telescope is moving. Lots of things are moving all at once. So sometimes it can be a little bit difficult to keep things in view, and often things track. And often with a telescope, if it doesn't have a motor on it, then you have to sort of manually keep it tracking on whatever it is you're pointing at, whether that's the moon, or if you're looking at a planet, or you're looking at deep sky objects. Again, keep in mind everything in space moves, and
and and
constantly doing so.
and Toshi, we're seeing one of those great big Maria regions. I think this is uh, the Sea of Tranquility. Um, I'm a little disoriented because of the way that the views are flipped here, and I don't have my map immediately with in front of me here. Does that look, or is that actually might be the other one, Serenitatis?
Yeah, I think you're centered kind of on Serenitatis
Yes, I
at
think
the
that's
moment. So
correct.
the Sea of Serenity.
The
Um,
reason I remember that, Toshi, is because it's got a ray that sort of goes right through it. I was noticing that this afternoon.
That's correct. And let's see if I kind of flip it in my own mind. There's kind of what we're looking at is sort of the boundary between the Sea of Serenity and the Sea of Tranquility. You can kind of
Okay.
see where that mountain range is there, and kind of sort of on the left side, kind of near where there's three largest craters in the Maria, sort of in the lower below center and just a bit to the right. Kind of still outside of the mountain range there, and kind of between the two Maria. That's around where Apollo 17 landed. So we're
Hmm.
getting to see where some of the Apollo missions landed.
All right. Well, let's see if I can go ahead and continue our trip on the other side of the moon here. Come back. Oh dear. I got to be careful here, Toshi. I don't want to have my telescope license revoked.
Yeah, don't fall off the moon.
There we go. Don't fall off. All right. Well, there's the edge. That's comforting to see.
And in this view, along the edge here, you can see again, that sort of that waviness right along the limb of the moon. And again, that comes from the scintillation within our own atmosphere.
That's also,
That's,
we call that twinkling, right, Toshi?
and yeah, scintillation is just a fancy word for twinkling. And but that again causes is what makes it's the same thing that makes stars twinkle, is that the light from these objects, whether it's the moon close up or the stars, as that light passes through our atmosphere, that light is bouncing off the molecules in our atmosphere, and it sort of bounces this way and that way. It isn't able to make a direct line to your eyes, so that's what causes twinkling. And just like if you've ever been on top of a mountain or something, and you've looked down at the city, and there are metal things that are shiny on the city or something like that, and they look like they're twinkling too. It's that same effect. It's because you're looking through a significant amount of atmosphere, and the light that's reflecting off of those metal things, whether it's cars or street lights, anything like that, that's twinkling because the light is being distorted by the atmosphere itself.
All right. Well, the clouds are looking pretty good here, Toshi. I'm wondering whether or not maybe you could take us back to Stellarium and sort of show us where our next destination is.
Yeah, I can do that, but we can keep it on your view for just a little bit, just a couple comments that I'm seeing
Great.
in the chat. So someone
Okay.
says that they can still make out craters with the binoculars, which is great. Again, a lot of the larger craters, wonderful to see. And again, if you look towards the Terminator, that's where you get again that contrast with the shadows and give it that real three-dimensional appearance. Um, Yusef is asking if the mare are deeper than the light areas that surround it. And in general, yes, those would be the lowland or lowland areas of the moon where the lava could flow into, and the non Maria areas, so the lighter areas on the moon, they tend to be the highlands, and that's where you get more mountains and things like that. So they are a bit deeper, although I don't recall off the top of my head, what the difference is in the deepness. But they would be again where lavas had flowed into them.
Well, what's also interesting, Toshi, is depending on the depth of a crater beforehand, you can get it so that it looks like it almost completely covered a crater and just see a little bit of it. And as I was preparing and going through my atlases of the moon, I saw lots of examples um, where you just see a hint, sort of a ghostly remains of a crater that started out as a big deep thing and then ended up getting filled up by the lava.
Yeah, there's a lot of complex geology, or it's not really geology since geo refers to Earth. I suppose it would be
Selenography, I think we say.
selenography, yes, for Selene, which is the ancient name for the moon there. But the moon again, it's a wonderful target, especially if you're just getting started in astronomy. You can spend hours and hours just looking at the moon. Of course, you can look at it naked eye, which again we hope everyone's doing for observe the moon night. And I will say that again, this is International Observe the Moon Night, which means that there are events happening all over the world right now, and this is an effort by NASA to try to get people to be looking at the moon. So this is one of many events. So we're happy for those of you that have decided to join us. Again, we thank you for that. We do want to mention that the captions that you're seeing to go along with the video, the closed captioning is brought to us by the Foothill De Anza Foundation. So we appreciate their sponsorship to get those captions on screen for us here. But the moon again, wonderful target to be looking at. You can spend hours and hours looking at it. If you ever get a telescope, or if you have a telescope, again, it's a wonderful target. It's there a good portion of the nights. It's even good in light polluted skies because it's easy to pick out. A lot of deep sky objects, which a lot of people get really excited about because they see Hubble images and things like that. They can seem a little bit disappointing when you first get your telescope. A lot of times it's not just a naked eye view. Those Hubble images, they've been stacked, and sometimes it's several hours of images that have been stacked together to get the detail that you see, as well as the space telescope being in space. But the moon is very rewarding, whether you're looking through binoculars or even through a telescope. And again, just keep looking along the Terminator. It does get very bright if you're looking through binoculars and telescopes. So they do have moon filters that you can get for eyepieces that help. It's basically a neutral density filter to help stop down the light a little bit so that your eye doesn't hurt. Because it can feel like if it's a bright moon, it can feel like someone's shining a light if you're looking through an eyepiece right in your eye. And if you're looking through an eyepiece, that means you're just looking through one eye. So it feels like someone's just shined a flashlight just in one eye. But I see we're back around Clavius, Mike.
Yep, there's Clavius. Amateur astronomers sometimes use Clavius as a way of telling how clearly their telescope is working. You'll notice there's at least three, and actually you can't quite see the fourth one that's at the end of the. Uh, they're sort of growing smaller as you go in a little arc. And amateur astronomers use that to sort of see what the seeing or what their telescope, what the performance of the seeing or the telescope is. I also noticed something that's right down more toward the terminator there, that's just below Clavius, and it looks like there's some real nice contrast there right underneath the crater, and it's very dark. And I don't know what that, if we had a little bit more light, it might be clearer to me exactly which that one is, but I can't tell just by looking there.
Yeah, that looks like it's another crater. I'm looking at my moon map here, and that's
Okay.
another crater. Looks like Blancanus, Blancanus, Canus, Blancanus. Um, Probably some scientist of note there. Um, but yeah, that's another crater. So that one, just judging by the shadows, not only is it right along the Terminator, I'm guessing because it is so much in shadow that we're looking at the shadow inside of the crater. So I'm guessing that that's probably a deeper crater than Clavius. Possibly
Hmm.
shadowed by the shared wall between the two. Um, and that fourth crater that you were talking about, Mike, it's sort of, if you're looking at Clavius, again, the central crater that we've got our view centered on, it's kind of at the sort of the about the 1 o'clock position. Again, it's sort of half in shadow. I can sort of barely make it out there, but it's right on the rim of the crater there. But if you look at, there's another crater, again, sort of on the rim, the largest of the ones that's inside of Clavius. That's another one that looks like it has a central bulge or central peak at the center of the crater there. So again, common feature. Um, there's another question in the chat that we're seeing here about how does the brightness of the moon compare to the brightness of the sun? Um,
Good question.
that is a good question. Trying to figure out how to put it in relative terms. Um,
Well, I think Toshi, I mean, I could take a stab at it. As far as the brightness of the moon versus the brightness of the sun, I can't give you a number, but I can tell you just the way that the moon shines is quite different than the way that the sun shines. The sun shines by making of energy through the conversion of hydrogen into helium, and the moon just shines by the reflected light of the sun. Um, so, um, so I'm not sure exactly how to give a number for that, um, but certainly the mechanisms by which uh, the two uh, the two objects make their light is different. What are you thinking, Toshi?
yeah, that's right along the lines of what I would say. That the moon is reflecting the sun's light. So it's kind of like if you have sort of a light, in your room, then there's the light that's coming from the light that's in your room, obviously. But then if you look at the light that's being reflected off of your walls, it is being reflected, so it's not as bright as the light that's in your room. The moon does actually have what's called it's called albedo, ALBEDO, albedo. And that is the measurement of reflectance, how reflective something is. And so the moon has a fairly high albedo, which makes it nice and bright in our sky. Now, if we had a moon, say, that was covered with more Maria, that would give us, a darker surface, and so the albedo would go down and might not be nearly as reflective. And at some point, it might not be as dramatic. Now, the moon is also relatively close to us, so it's probably always going to be dramatic. But that has um, an impact, how reflective the surface is itself. This is moving off to a little bit of a tangent, but when Pluto was first discovered back in 1930 or so, um, one of the when we first found it, we thought it was a planet that was another sort of gas giant, and one of the reasons is because it was very bright. And one explanation for something being very bright, a planet being very bright, is if it's very reflective. Um, or if it's very, very large, if there's a large planet out there that's able to reflect a lot of light. It turns out that Pluto just happens to be very reflective, so it appeared much brighter. And so once we got some better data, we found out that, oh, it isn't a large, not very reflective thing. It's actually a very small, but also very, very reflective thing there. So, um,
Toshi, listening to talk about that as I'm watching I'm just sitting here watching the moon and the scintillation, the motion of the atmosphere. It's really settled down quite a bit now. Um, and you'll notice that, it was fairly warm here today. I suppose it was in the Bay Area generally a little bit warmer than yesterday. And so it's now that the Earth is starting to cool off, I think it's actually getting a little bit better than it was.
yeah, that's a big factor in scintillation is the actual heat that's radiating from the ground is distorting the light or
Yeah.
distorting the atmosphere immediately above the ground. So that affects scintillation as well. So generally, as things cool down, the you get less scintillation issues. So all sorts of things that amateur astronomers or even professional astronomers that think about when they're looking through a telescope. A lot of us maybe used to, you get a nice clear view of something like the moon or even planets or other objects out there, but you have to deal with the scintillation. So usually what people do is they take a series of photos. They might even take a webcam. There's cases where people take a webcam, they take a video, and what they do is they take the individual frames, and they do what they call stacking. So they'll take one image and they'll sort of put it right on top of another digitally. And the more frames that you can stack on top of each other, the more and more detail that you can get. So when you see those really pretty pictures, it's not just a single shot that someone took. There's 30, 40, sometimes maybe even 100 frames that they stack together, depending on how much detail you're looking for.
All right. Well, Toshi, I'm looking up and I'm seeing the clouds are looking okay at the moment, and I'm wondering if maybe there'd be some interest in going and taking a look at Jupiter.
Yeah, so why don't we go ahead and do that, and I'll switch back to myself for the moment while you get set up with
Okay.
that mic here. So we're looking uh, back at myself here, but what I would like to do is just very briefly switch over to a view of a moon map that I've been referring to as Mike was taking us on our tour here. And this map is comes to us from the NASA Science Visualization Studio, and we'll share a link at the end of our broadcast here. But this is a map that was specifically for September 27th at 3 a.m. Universal Time, which happens to be 8 o'clock on the 26th. Our time. And so this is what the moon looks like. This is how it's illuminated. And we've got several craters that are labeled here. The craters that we're looking at here was Clavius that we were looking at before. And we had those craters inside of Clavius that we were talking about there. Um, and the view in the telescope is a little bit reversed, but that's how it is. But if you were looking just with your naked eye up at the moon, this is the exact sort of shadow that we would see on this date and at that time. And there's a website maintained by NASA where you can put in any hour of any day of the year, and so you can get a nice detailed high resolution map from lunar reconnaissance orbiter data that shows the moon in some pretty good detail. These are those mountains that we're looking at before through the telescope, and you can get some pretty good detail here. If I zoom in a whole lot, of course, it gets very pixelated, but it's a pretty high resolution map. And again, they always make sure that the terminator shadow is correct for the time that you're looking at, because that varies again from night to night. So you can take a look and you can get this map for yourself for any date or time that you may be looking at the moon. So that's one thing to take a look for. Um, and but I did want to switch back over to my view of stellarium, and we were looking at the moon before, and I'm still centered on the moon. But in our last few minutes here together, I'd like to go ahead and focus in on Jupiter, which again, if you're looking at the moon, just to the sort of to the right of the moon, this one is Saturn, and the one after that, even further to the right, and it'll be brighter. That one will be Jupiter here. So let me go ahead and center in on Jupiter, and I'm going to zoom way in to Jupiter. This will be a bit more than Mike will be able to zoom in with his own telescope here, at least with his camera and based on the scene. But if we zoom way in, we start to see a few dots around Jupiter, and those dots are moons, and they show up all in a line there. And I can zoom in even more just in my view. This moon that's way off at the edge is a moon called Callisto. And then there's Jupiter, of course, in the center. And then there's a moon on the right side of Jupiter, in our view here, a moon called Ganymede, which is actually the largest moon in the entire solar system, followed by Io and Europa. And one thing that, again, I know we won't be able to get it in Mike's view, so I'm going to zoom in with the power of stellarium. If I zoom in on Jupiter, right now, way in. There's this black spot on Jupiter, and it's not a cloudy spot. This is actually the shadow of a moon. There's an eclipse happening on Jupiter as seen from Earth right now, and this dark spot here is actually the shadow of the moon Ganymede on Jupiter there, and that's actually happening right now. Again, I don't think we'll be able to see it in Mike's view through his telescope because I think Jupiter is going to be washed out, but we will be able to see the moons. But this shadow is going to be on Jupiter until about 11:30 tonight. So in Stellarium, I can speed up time here, and as I do that, you can see that shadow moving along. It's actually drifting a little bit, and we're looking at now the time is just after 10 o'clock local time here, Pacific Daylight Time, and you can also see the great red spot has appeared here. So if you had a telescope tonight and you're looking at Jupiter, you could see both a shadow on Jupiter as well as the great red spot tonight. It's not there every night. Jupiter, despite being a very large planet, rotates every 10 hours or so. So it spins around very quickly. In fact, if you could, to give you an idea of how big Jupiter is and how big that great spot is, if you took the planet Earth, you could line up 11 Earths right across the diameter of Jupiter. So Jupiter is 11 times the diameter of planet Earth, which means that if you're looking just at the great red spot, you could fit, I think you can tell if I tell you that it's 11 to go all the way across here, that you could easily fit two, maybe three. It's actually about two Earths that you could easily fit inside of the great red spot there. And that spot, if you don't already know, is a gigantic storm, like a hurricane on Jupiter. And it's a storm so big you could fit two planet Earths there, but also a storm so big that it's been raging for over 400 years. And it's probably been going on longer for that. We don't really know because, again, as I mentioned earlier, Galileo was the first to take his telescope and look up at the moon. But we've only had the telescope for 400 years. So we've only had the ability to even detect the great red spot for the last 400 years or so. It's probably been going on much longer than that. There is some indication that the great red spot is getting smaller. We're not entirely sure why that is, but it does seem to be getting a little bit smaller. Some have speculated that in about 20 years or so, if it continues at this rate of shrinkage, that it may disappear in the next 20 years. But then again, we're not entirely sure why it's shrinking, so it may come back. It may be some sort of cyclical thing, and the Great Red Spot may come back. At one point, it was big enough to hold three planet Earths. Now it's down to two. Um, but that's Jupiter and its bands, and you need a pretty high-powered telescope to see. Well, actually, you don't need a very high-powered telescope, but you need a better control of exposure that we can get with Mike's phone, which he has attached to his telescope. But regardless of your optics, Jupiter is also a fun thing to look at with binoculars, and depending on how good your binoculars are, sometimes you can see the moons as well. If I turn off these labels for a moment, and I give you an idea here of what a binocular view would look like. This is if you've got some 10 by 50 binoculars. This is the view. This is similar to a view of Jupiter that you would get, and you can just sort of barely make out that there's an extra spot there to the right, and that would be Ganymede. And then up and to the left over there, that is Callisto that you can see there. So you can see a little bit of the moons through binoculars, but you really want a telescope view to get a nice detailed view of Jupiter and its moons there. So
It's very possible if people are trying to look at it right now with binoculars, that because Callisto is so far out from Jupiter, it may be fairly easy to to. It'd be interesting to hear if people are able to see the moons with their binoculars tonight.
And again, a question in the chat that we're seeing, would that eclipse on Jupiter be a total solar eclipse? And I'm not entirely sure. I don't think so. To get a total eclipse, the moon would have to completely block the sun, which I don't think Ganymede is able to do. On the other hand, Jupiter is much, much further away, so the sun would appear smaller. But I think Ganymede is small enough that you wouldn't be able to block the sun uh, with Ganymede if you were looking at it there. So it would be what's more called an annular eclipse, which comes from annulus or ring. So you would still see a ring of the sun around that moon. So it wouldn't be totally eclipse, but it would
Great,
be interesting.
great question though.
All right.
So Toshi, I think I got Jupiter in the field.
All
If
right.
you want to spotlight me, I'll see if I can zoom it in.
All right. Well, let's go ahead and do that. So got
Okay, I
uh,
do see it. Let's see if I can move it a little more to the center and then I'll try and zoom it up.
so Jupiter again, a nice target, one of the five classical planets. And the thing about Jupiter and the other planets is that they appear to wander in the sky, and that it's a little bit less noticeable from one night to the very next night. Like the moon changes pretty dramatically from night to night, but over time the planets do they wander in the sky. Typically, they move more from a west to east direction, whereas the stars they tend to move generally from east to west. So the planets they wandered around in the sky. So it comes from an ancient Greek word planetes, which looks like the word planet with an es at the end. And they were known as wanderers because there were these five objects in the sky that didn't move like anything else. Even though they look like stars, they look like they were these wandering stars in the skies. So that's where the word planet comes from. And the ancients recognized five that we could see. We could see Jupiter and Saturn and Uranus, or no, Jupiter, Saturn, Mars, Mercury, and Venus. But looks like a good view of Jupiter there, and Callisto down and to the right of Jupiter in our view, and then those three other Galilean moons, the four moons that we can see there collectively, they're referred to as the Galilean moons. Because they were first identified by Galileo Galilei himself 400 years ago through his telescope. And what he noticed is what you're seeing now is that they appear all in a line. They look like a nice diagonal line there. And when Galileo looked from night to night, those moons do move around. And sometimes he saw four of them, and sometimes he saw three, and sometimes he saw two on either side of Jupiter, and sometimes he saw, like we see here, three on one side and one on the other side. But he did notice that they were moving, and that's what makes these moons interesting. So not only are we looking at international observe the moon night, but interplanetary moons as well, looking at the moons of Jupiter here.
So Toshi, can you remind me what is that one that's very close to Jupiter?
So the closest one is Ganymede,
It's
largest
Ganymede.
moon in the
Okay,
solar system.
because that's the one that's casting the shadow on Jupiter, right?
Correct.
Okay, sorry, I wasn't. I was focusing on the telescope there, and that one that's way far out, way down to the lower right is Callisto, correct?
That's right. That's so Callisto by itself, which is a pretty close second to largest moon. Both those moons they are larger than our own moon. Forget off the top of my head. I think our own moon is like number three or number four of largest moons in the solar system. But Callisto and Ganymede for sure larger than our own moon. Ganymede, the largest one in the whole solar system.
And I'm sorry, and which one is Io?
So Io or Io is
Io?
the second closest to Jupiter there. So going in
Okay.
your view here, so there's Jupiter, which is the big bright thing. And then there's Ganymede, and then above and to the left of that is Io, and then above to the left of that, just in the corner of our view in the far upper left is the moon Europa. Um, and
I
each
know
of those moons is interesting in its own right, and they
a
all
lot
have
of my
distinct features.
a lot of my students really like Io because of the volcanic activity.
Yes, one of the things I like about IO is that it's really easy to spell. I-O. That's probably my favorite thing about
Even
IO.
for you, Toshi.
Even for me, even I can spell
Incredible.
IO. Um, so again, a couple more questions about Jupiter and the moons. Um, Can we see the great red spot with a good pair of binoculars? I don't think so. I think the great spot is well, I
No,
my
I don't think you can see that with binoculars. I know I have just been barely able to see it using this little 4.5 inch objective telescope. Um, I would be really surprised if you could get enough of a disc with binoculars. It depends. There are mega binoculars. Um, so I suppose, but not with a standard issue, sports, typical sports binoculars. I don't think it would be possible to do that.
Yeah, I don't think you can do it in binoculars, but I don't think you need a very powerful telescope. So, you don't need the Hubble
Yeah,
and you don't need, like a
good point.
20-inch telescope or anything like that. But even through a modest telescope, you can see the Great Red Spot. But I believe you do need a telescope. Another question about is there a way to be on Jupiter and view the sun from the eclipse location? Is there a way to be on Jupiter and view the sun from the eclipse location? Um, as a practical matter, Jupiter is a big ball of gas, so there's no place to land. But I suppose if you could, be in a spaceship and you could sort of hover yourself right over where we saw that shadow in my stellarium view, then you would be able to see the moon eclipsing the sun, even if it wasn't a total eclipse. You'd still be able to see that there. But again, you would have to be at Jupiter. And eclipses are all about perfect alignments. So when you get a full moon, well, I should take the reverse. If you have a new moon, um, or you can only get a solar eclipse when there's a new moon, but there is not a total eclipse every new moon, and that's because the moon is usually a little bit above the sun or a little bit below the sun when around the time of new moon. So it's only when you get that exact alignment. So if you could get yourself exactly aligned, then you would see an eclipse. Uh, then there was a question about whether or not Jupiter is in retrograde motion or not, and I would have to look that up. I forget if
I
Jupiter.
I I don't think I'm I don't think so, Toshi. Retrograde is a small amount compared to the complete travel of the planet. My guess, and of course, you're right in the middle of retrograde um, when you're at opposition, and we know that Jupiter's not in opposition now. Mars is a different story, and I can't see Mars from here, but Mars is something that's going to be interesting very soon. I didn't mean to take you off of the question there, Toshi.
Yeah, no problem. And just I will mention though that it does look like that Jupiter is not in retrograde, that it is in prograde. But I will mention that it is getting closer to Saturn, and something to look out for as we sort of
Hmm.
start to wrap things up for this evening here is that in December, in particular, if you're looking in the skies, especially the western skies, Jupiter and Saturn, they're getting closer and closer together. And around the 21st of December, I'd have to double check my notes, but it's right around the 21st of December. Jupiter and Saturn are going to get so close that they will be practically on top of each other, and it's the closest that they will have appeared in the sky for about 400 years. So watch, through the rest of this year, watch for Jupiter and Saturn to appear to be getting closer and closer and closer to each other. And by December, they might even just look like one very, very bright star instead of two distinct star-like objects. They'll be close enough that they might look like a single bright object there. So
That's right near the winter solstice, right, Toshi?
yeah, that'll be very close to the winter solstice time there.
Okay. Any other questions?
Um, Not seeing any others. Someone was asking if you could decrease the exposure on your camera to see if we could see any surface detail on Jupiter.
Yeah,
Unfortunately, not with this setup. Um,
yeah, we're still working on the ideal setup here. and I can do the zooming with the smartphone, but we haven't figured a good way on the smartphone to be able to get it to while during the broadcast to be able to change the exposure. So sorry about that, but stay tuned. Um, Possibly if there's another event where we do this, we might be able to improve our view a bit and the coverage of the functions that I can do from the phone here, but can't do it tonight. Sorry about that.
I will say that the brightness of Jupiter is that's mostly a function of the fact that we're using Mike's phone to broadcast this. If you were looking directly with your own eyes through the eyepiece, then you probably would be able to see a fair amount of surface detail. But because we're looking through a phone and there's electronics, and the phone is just not as responsive as the human eye, so you would be able to see it with your eye, but just not through the camera. That
Yes, if you were able to look through my telescope right now, you'd see what I'm seeing, which is the surface, the cloud tops. Sorry, that's sort of a cheap thrill there, but I thought I would just say that certainly with a telescope, a small telescope even, you can see not only the moons, but you can see the surface detail as well.
All right. Well, we are getting kind of towards the end of our time here together. I did see in the chat one last request to take a look at Jupiter one last time here. So let me kind of get that set up here. So just give me a moment here to get it set up. But in fact, maybe I'll go ahead. I will spotlight my view now so that we can see I'm back on Jupiter. And let me go ahead and keep zooming in. This is the current time. Again, just 8:30 here. And again, looking at where that shadow is on Jupiter there. And I'll kind of wrap things up just by sort of speeding time up a little bit here. You can see again that shadow transiting along with Jupiter and the great red spot. And about 11 o'clock is when that shadow disappears, at least from our view here. And looks like in Stellarium, Jupiter's gone below the horizon there. So but I will wrap things up here, just showing you one last thing here. So I'll go ahead and switch my view to last thing. So other ways that you can explore the moon, there's a QR code there so that you can get to this slide and see it for yourself if you like. But that place where I was looking at before where we could see the detailed map of the moon, that's from this link here, the NASA Moon Phase and Libration link there so that you can grab those images there. Moon Trek is another great site that you can go to, and you can really zoom in onto surfaces of the moon and do your own exploration of the moon. And you can go visit the Apollo landing sites and see where the landers are and get up close and see some of the footprints and things like that. If you're interested in the moon, you can always make a moon observation journal. There's a nice downloadable calendar that you can download from this link. And if you want to learn more about NASA's plans to return to the moon, that's going to be all a part of the Artemis mission. So there's a nice website with some STEM activities from the NASA Artemis program to study the moon. If you'd like to print out your own participation certificate for participating in 2020 Observe the Moon, you can go to this link right here, participation certificate. And you can go ahead and personalize that with your name and tell all your friends that they missed out if they did, and show your NASA certified International Observe the Moon participation certificate. And even though we are wrapping up things here tonight in a little less than half an hour, if you go to the Chabot Space and Science website, Space and Science Center, they are going to be doing some moon observing as well. And they've got a couple of very lovely telescopes, large telescopes at their observatory. And I'm pretty sure that they'll have a better setup than our phone. But that's if you want some more detailed views of the moon, you can go check out the Chabot Space and Science Center um, feed starting at about 9 o'clock tonight, Pacific Daylight Time here. But with that, I'll go ahead and again wrap things up, bring it back on myself. I want to thank everyone for tuning in tonight. Hope you enjoyed yourselves and got a chance to observe the moon for real. And if you were stuck inside looking at the broadcast here, we appreciate that. But again, go ahead, step outside, take a look at the moon. It's beautiful tonight. Luckily, we had nice clear weather. Mike, anything that you'd like to, any final words that you'd like to say?
I just want to thank everybody for tuning in tonight, and just to let our friends from who come to the planetarium typically know that we miss you, and we can't wait to get back with you when the health conditions allow. But thanks so much for helping us keep a connection with you, and I hope you had a good time tonight. Back
All
to you,
right.
Toshi.
Thank you, Mike. All right. So once again, thank you to NASA for International Observe the Moon Night, and thank you again to our sponsor, the Foothill De Anza Foundation, for making the closed captioning on this feed possible. And on behalf of everybody and the entire staff of the De Anza College Planetarium, thank you everybody once again for tuning in. Have a great night. Enjoy the moon, enjoy Jupiter, enjoy Saturn. Take a look and watch those two planets get closer and closer in the sky as we approach the end of the year. And as long as it's safe and clear, keep looking up and wishing you clear, dark skies wherever you are. So thank you all very much and have a good night, everybody.